Hello everyone and welcome to this beginner course on machine learning. My name is Ethan Parker. In our last lecture we introduced machine learning, talked about its significance and introduced the three main types of machine learning development, that is, supervised, unsupervised and reinforced. Today we'll delve into the main foundational topic that is critical to the success of any machine learning model. Of course I am talking about understanding data. Our focus will be on three key areas, which are the importance of data in machine learning, the types of data we encounter, and an overview of data sources and formats. Grasping these concepts will give you a strong foundation as we explore machine learning techniques in the future. Let's get into it, shall we? So what is the big deal? What is the importance of data in machine learning? Data is often referred to as the new oil in the world of technology. It is that important. Here is why. Firstly, machine learning models learn from data. They identify patterns and make predictions based on the information they receive. If the data is inaccurate or insufficient, the model will likely produce flawed outcomes. Therefore, collecting high-quality relevant data is crucial. Moreover, data plays a vital role in determining the performance of your model. The saying garbage in, garbage out perfectly captures this concept. If you feed your model poor quality data, it will lead to poor quality predictions. This is why preprocessing and cleaning data is an essential step in any machine learning project. Additionally, data allows us to different scenarios and variations. For example, consider a model predicting house prices. The more varied data we provide, different house sizes, locations, market trends, the better our model can understand the factors affecting house prices. So, in summary, data is the foundation of machine learning. It's essential not only for training models, but also for making informed decisions about their structure, complexity, and capabilities. Understanding the nuances of data is the first step in becoming proficient in machine learning. Now that we've established the importance of data, let's discuss the different types of data we encounter in machine learning. These are numerical and categorical data. In machine learning, numerical data obviously refers to data that is represented by numbers. This means it consists of quantitative values that can be used for mathematical calculations like measurements or counts. It allows for analysis through arithmetic operations like addition, subtraction, and more. Essentially, any data point that can be expressed as a number is considered numerical data. Now, numerical data can be broken down further. There are two categories of numerical data. First, we have discrete data. Discrete data refers to a type of quantitative data that can be counted and consists of distinct, separate values, meaning you can only have whole numbers and not fractions or decimals within a specific range. Essentially, it represents countable items like the number of something, such as the number of students in a class or the number of cars on a highway. These cannot be fractional. We also have continuous data. Continuous data refers to data that can take on any value within a specific range, meaning it can be measured and divided into infinitely small parts like height, weight, temperature, or time elapsed. So it is not restricted to specific discrete values like whole numbers, but can fall anywhere within a given range. Pi is a very long decimal number, right? So it would be continuous data. So that is numerical data. We also have categorical data. This refers to data that can be divided into distinct groups, just like numerical data. Categorical data can be further broken down. It can be subdivided into nomical and ordinal data. Let's take nominal data first. Nominal data is a type of qualitative data that involves labeling variables into distinct categories without any inherent order or ranking, meaning the categories are simply names or labels with no numerical value or hierarchy. Basically, this is data used to categorize things without assigning any quantitative value or order to them, like classifying people by their hair color. Brown, blonde, black, red, and these days purple, pink, and puce. No color is considered higher than another, except puce. That is in last place, no matter what. Fruit is another example. Apples, cherries, and grapes. No order. Just good vitamins and plenty of carbs. So this is nominal data. Categorical data can also be ordinal data. You may have guessed that ordinal data has a clear order but doesn't have a uniform scale. For instance, a customer satisfaction survey with ratings such as poor, average, and excellent is ordinal. Grades can be A, B, C, D, and F. A student might be a freshman, a sophomore, a junior, or a senior. Other types of data exist as well, such as textual data, which may come from various sources and require specific processing techniques to be analysed effectively. Understanding these data types is fundamental as they dictate how we pre-process and model our data, influence the choice of algorithms, and affect the interpretations of our results. Now that we understand the importance of data and its types, let's explore where we can obtain this data and the formats in which it is typically stored. Data sources can come from all over the place, and we can cover many here. There are public data sets. Many organizations release data sets for public use. Websites like Kaggle, UCI Machine Learning Repository, and government websites provide a wealth of data sets. Data can be mined by web scraping. This involves programmatically extracting data from websites. Note of warning here, although it can yield a large quantity of data, ensure you adhere to legal guidelines and website policies. Things like ethics and the law are not supposed to be mere suggestions. How about APIs? That is application programming interfaces. APIs are a set of rules and protocols that allows different software applications to communicate with each other, enabling them to share data and access functionalities without needing to know the internal details of each other's systems. Basically, these act as a bridge between applications to facilitate interaction and data exchange. For example, Twitter or social media platforms provide APIs that allow researchers to collect user data in a structured format. And of course, we have old-school databases. Organizations often maintain their own databases. These can be SQL or NoSQL. These databases house operational data. Skills in data querying are crucial for retrieving information from these databases. By the way, if you don't know, SQL stands for Structured Query Language. This is a standard language for database creation and manipulation. Oracle, MySQL, Access, and other databases are SQL. MongoDB and Redis are examples of NoSQL databases. So now we're out there collecting data. What will we find in all of these places? Data formats come in all shapes and sizes. You may have experience with CSV. This is comma-separated values. It is a common format for storing tabular data. It's easy to read and write, but lacks advanced features like data types. You probably have seen Excel export data in CSV. How about JSON? This is JavaScript Object Notation. This is a lightweight format often used for APIs. Google, Facebook, Twitter, YouTube, Flickr, and OpenStreetMap all use JSON. XML is another popular and widely used format. XML stands for Extensible Markup Language. This format is very structured. It is really good at handling complex hierarchical data, and so it can also be much more difficult to get right and can be wordy. Of course, you all know Excel. This is a format that is still very widely used for storing and analysing data, especially in business environments. Understanding these data sources and formats will empower you to effectively gather and manage data for your machine learning projects. In conclusion, data is a critical component of machine learning. Its quality and type play a significant role in shaping the success of your model, and being familiar with various data sources and formats will allow you to gather and pre-process data effectively. In our upcoming lectures, we'll build on this knowledge as we dive deeper into data pre-processing techniques, feature engineering, and specific machine learning algorithms. Thank you for your attention. Cheers and have a blessed day. Please like and subscribe for the sake of Tech Skill Hub and all the people who drone on and on about high-tech stuff. This is Ethan signing off.